job at Union Pacific or any railroad for that matter, we always have a safety briefing. So I'm going to run through a few things. Can I have a volunteer to call 911 if something happens? Your name? Kelsey. All right, Kelsey. Thank you, Kelsey. Let's talk about our exits. We have an exit sign over here. We can take that one. I believe there's an exit. We're not going to take, in a chance of an emergency, we're not going to take the elevators. We'll take the stairs down this way. And then there's stairs out to your right as well that go down and out of the building. I think you have to go down 2 floors on this way, 3 floors on that way. So that'll be your emergency exit. If somebody goes down, do we have a CPR and an AED responder? Anybody? That is CPR qualified. What's your name, sir? Luke. All right. So Luke's gonna respond for us for that. Can we get a head count too, just so if we do have to evacuate the building, we'll know how many people we do have? 38. 38? Okay. 38. So you'll be in track of that. Got it?
I can't wait.
All right. Does anybody have any questions regarding our safety briefing? Any safety related? Watch out for chairs. The chairs are, pushing your chairs when you leave. We don't want anyone to trip and fall, have any injuries like that. All right. Well, I think we'll get started. Yep.
I'll start. Stephen Abalaki, I'm the HR Director for Union Pacific Railroad of the Northern Region. I'm going to talk a little bit, do a few slides about the company, then spend more time talking about the positions, the operation management training positions that we have available. This is why some of you are here. Won't spend too much time on these slides, they're very high level. Hopefully you did a little research on the company. This slide talks about our mission and our values. If you glean anything from this slide, the one thing I would just tell you is that, Union Pacific is a railroad, we're a service industry, we provide a service. We don't build anything, like products, like we build trains, but we don't build anything, we don't sell a product, we don't manufacture anything, we move product, that's what we do. So the one thing that, regardless of what department you're talking about or you're involved with or you may know someone in, we're looking for reliable people with strong work ethics that have to show up to work. Because if our employees don't show up to work, things don't move, and that's, people move product. Well, from this slide, you'll see that's our high level, if you would, territory map of our track. And those are all of our, what we call service units on the railroad, kind of like nodes, if you would. It's a little bit outdated. 2012 year end, we did about $20 billion of revenue. We have 45,000 employees on 32,000 miles of track. If you can get anything from this slide, is that if you want to work for Union Pacific Railroad in the operating department, which is what we're here hiring for, you can work anywhere on that map. So generally speaking, we'll kind of let you narrow it down to a region. We divide up the Union Pacific into 3 regions, the north, the south, and the west. But all that said, when you get an interview, they might ask you, hey, what region you're interested in. So we'll let you narrow it down to about 2,000 square miles. But after that, we're going to put you where we need you. So you have to be willing to relocate initially, and then throughout your career. The way to get ahead at Union Pacific is to learn the network, learn the many shops, the tracks, the yards, and the way to do that is, of course, after you become comfortable and proficient at one territory, you move on to the next one. Union Pacific is a little bit unique from other railroads in that we operate in many of the fastest growing states in the United States. Top producing agriculture states, of course, we're everywhere in there. Commodities, industrial sand, lime, aggregates. It's amazing how, I think I've been with the railroad about 16 years now, and the industry didn't change too much year to year, or even decade to decade, but now it's like, I'm sure you all know about like the need for sand, for fracking, and just automotive, how it kind of comes and goes, and just things change on the dime. Actually, in the agricultural issues, I'm sure you heard about the tsunami overseas a couple of years ago. Well, as a result of that, they couldn't produce their own grains. We had to export record amounts of grains from the United States, all of which, well, much of which is moved by train, particularly in the Pacific, because that's where we operate. Coal, we move coal from the north to the south, power supplies. Port access, we have a lot of international shipping, of course, intermodal, and border crossings. We do a lot of business, of course, with Canada, Mexico, very integrated with those railroads. We're a very diverse commodity mix. You know, what this really tells you is that we ship everything. I mean, if you name it, something you touched today or touching right now, whether it be your clothes, the chairs that you're sitting on, something, you know, Union Pacific hauls just about everything. You name it, you know, we more or less ship it. So this is something, it's, again, kind of new in that being diversified is great because it's a good strategy. It's something, you know, goes down, if you have a downturn in 1, 2, or 3, even 3 different commodities, you know, being diversified helps you insulate that from, you know, the impact that it has on your business. So, you know, like, I'm sure you all heard how autos have gone down significantly over the past few years, but now we're coming back. But, you know, when that was happening, as well as, you know, industrial products, housing was kind of getting hit hard too. But, you know, chemicals were up, and intermodal was up, and agricultural products was way up, you know. So you have that little buffer of being more diversified rather than all your eggs in one basket. Most people don't think of Union Pacific or railroads in general as being green, you know, as far as good to the environment, but we're very fuel-efficient way of shipping goods. Almost 4 times more fuel efficient than trucks, and much cleaner, of course, due to the efficiency, you know, much less emissions, and emission standards are being improved almost every year. The quality of locomotives, you know, the government mandates the amount of emissions it could put out, and actually has future mandates so that you have to meet, like cars, right? I mean, you hear about cars have to meet certain emission standards, no different for locomotives.
It's logical. You compare a steel wheel or a steel rail, the friction coefficient is so tiny compared to rubber tire on concrete. So it's that kind of way you can get major efficiency gains.
Yep. So just some interesting, I guess, little known facts. But, you know, we obviously move a lot mass product. So there's some examples about that. 270 million tons of coal. That's actually probably less now. A lot of beer. Really, it's a quantity. You know, we move significant amounts of quantity of products. We're the first railroad to ship wind turbine parts, including the 135-foot blades. I drive across Iowa quite regularly, and you know, we were the first railroad to move those blades are huge. I mean, they're huge. And trucks move them too. We were the first railroad. So I'll give you a little overview of the operating department. All the positions that we're hiring for, whether it be engineering, mechanical, or transportation, that's what comprises of our operating department, which is the largest department at Union Pacific. Now, the operating department is broken up into 4 different areas. You got transportation; those are the people that move the goods. We'll talk about this a little bit more. Engineering, everything below the wheels of a train. You know, all of our infrastructure, the bridges, the rails, even our buildings. And then mechanical, you know, the maintenance and repair of locomotives, as well as our freight cars. And then you have support services. Those are the people in the departments that support all of those departments, like centralized network planning operations, train dispatching, things of that nature. You need all of these to run around. And there's 45,000 employees at Union Pacific, most of which work in the operating departments. So I'll talk about transportation a little. What transportation department does is literally they move the freight. So they take everything from one yard and move it across the railroad to another yard. They switch cars within the yard, so when a train gets to a yard, you know, in a perfect world, that train would go from point A to point Z as a whole train, but that's never the case, and that would be really nice if that was the case. But it gets to a yard, and if it's carrying 150 boxcars, you know, all 150 aren't going to the same customer. Maybe 1 is going to one customer, maybe 10 is going to another. There's a switching operation, so it pulls into a yard, and it's pretty complex operations, all different types of yards, which I won't get into, but how the switching is done varies between yard to yard. But as you can see, you know, you've got trains in the middle or boxcars in the middle to move it to the end of one to the beginning of the other. It's a logistical nightmare, you know, and that's what they're responsible for as well. A lot of stuff that happens inside the yard, refueling, recrewing, all of that stuff. So at the end of the day, they're really responsible for the on-time delivery of freight to the customers, but they can't do that without the other departments, right? You can't get it there if you don't have a reliable network of rail. You can't get it there if you don't have reliable locomotives or freight cars. I'll let these guys talk a little bit about, because these are all Michigan Tech grads, for one. They'll talk about themselves, what they did when they graduated, what they do for the railroad now. Jesse's in the mechanical department.
Jesse Vandenberg, mechanical department. I'm currently in Kansas City, just graduated this past May, and I'm in the car side of things.
I'm Victoria Demers. I just recently graduated from Tech as well with a mechanical engineering degree, and I'm down in Texas right now.
So as you can see, we have 8,000 locomotives and 78,000 freight cars. So there's two different sections if you're going to be in the mechanical department. You can either be on the locomotive side or the freight car side. And the locomotive side is more of a shop type setting, whereas the freight car side you can be on the yard or you can be also in a shop type setting.
In the engineering department, that's what I'm in. I'm Tom Bartlett. I'm working at UP 5 years now, and I'm a 08 Michigan Tech EE graduate. And the engineering department is basically all the infrastructure that trains run on. So the biggest part of that, of course, is the track. The track, the bridges. We'll hire civil engineers to take care of those. And we'll go into more detail about a little more about infrastructure here quickly. So, as a civil engineer, what you do is build and maintain all the structures, the bridges, and the biggest part of the track on the whole system. And you're given about 20 to 30 employees to do so. And keep in mind, this is after about a couple of years of training, but that's what we're hiring people for, is to do management here. If you're an electrical engineer, what we're hiring people for is to, again, take care of the infrastructure, but in this case, it's all the electronics in the track, which consists of three things, really. The signaling system, is the lighting system that tells when trains can go and stop. It's controlled by the dispatchers in Omaha, the dispatching center. You have your grade crossing types of things where you've all been waiting for a train before, and you'll notice 20 seconds before the train gets there, the lights start flashing, the gates come down. That's that kind of electronics that make that work. And the third piece of infrastructure is defect detection systems. So I'll talk about a couple of those in detail here. So we'll get geeky for a second. One example of a defect detection system, it's a great engineering example, is this wheel profile measurement system. And what this does is use cameras and lasers to take a picture of the wheel as it goes by at 70 miles an hour. It sends the picture of that wheel into a wayside data center, basically, with servers. These servers process that image and take measurements. And with these measurements, we can basically plot the wheel out. So here's a great example. This blue plot is a new wheel. And over time, due to plastic deformation, the metal bunches up and we get this kind of harsh point up there. And over time, that point becomes so pointy that it can actually break that piece off and there's major derailment risk. And here's just a question I'll pose, a great mechanical engineering question. Do you think a train wheel set has a differential? Keep in mind, trains do go around curves. So you know what a differential is. It allows wheels to rotate different speeds. But who thinks a train wheel set has a differential? Let's get a show of hands here. 2, 3. And everyone else thinks it's just a straight beam across. All right. I'll show you a picture of one. This is a wheel set. Notice it's just a straight beam here. The neat thing about this is when it goes around a curve, the whole wheel set shifts over a bit. And when that wheel set shifts over, you're changing the effective diameter of the wheel. So it actually, go back to that. As it shifts over, the diameter becomes longer so it can rotate slower. So we're not changing the speed of rotation, we're changing the actual diameter of it. This is 1850s technology, it's really neat. So one more sensor that we're talking about is, get this problem of flat wheels. If a trainman will tie a train down to make sure it doesn't go anywhere while he goes on a break or ties up for the night, he'll come back and he might just forget to untie the brakes. A common problem. So he'll take off and this wheel is sliding. It's not rolling like it should. And what that causes over time, eventually it breaks loose, but it's just pounding on the track. It rotates a little bit, then goes pow, it rotates, goes pound. That could actually break the rail apart. It's a ton of force. So a question I'll pose to you is what kind of sensor would you choose to detect a flat wheel going down the track? accelerometer. So something to measure the shake. That makes sense? Anyone else? There's all kinds of answers. This is an engineering problem. That's what makes engineering so fun. What we end up doing is using what's called a strain gauge, a little strip of metal we'll weld up to the rail. When the wheel goes over the rail, the strip of metal bends ever so slightly, changes the resistance, we get a current reading that's different, and we translate that to weight. We weigh this thing, we weigh each wheel 16 times, it goes through this 50 feet. And if you think a wheel is perfectly round, it's going to weigh exactly the same. A kip is 1,000 pounds, so it's going to go like 30 kips, 30 kips, 30 kips, 30 kips, 16 times. If it's got a flat spot, it's got to go 30 kips, 30 kips, 30 kips. What if it's 65 kips? Pound the hell out of the rail, right? And we have that exact weight. We can compare that peak weight to the average weight across all of it. We've got a great idea of how flat this wheel is. We can take care of it right there. I get excited about this stuff, sorry. What about mechanical?
Yeah, and going off of what he just said, that's really important for the car department and the locomotive department, because those alerts that those sensors are sending to they send it to a program in the mechanical department, and that gives us an alert that, hey, we have a 90 kip wheel out here. That means there's a flat spot, so we got to change that wheel out. Or if there's a high tread, like you showed on that one, that means we got to change that wheel set out. Just like it's all basically derailment prevention. And going off of that now, what you'd be doing, like if you, let's say you got put in a yard, you'd have trains coming inbound, you'd have to do an inbound inspection on those trains. What you'd be looking for is make sure that all the brakes are able to set. You're looking for defects on the cars, looking at the brake rate and all that, that nothing's binder following just for derailment prevention. If you have something too bad that you can't fix out there, that'll all get sent to the shop. If you can fix it out there, you do it right on the tracks. And they also have expediter tracks where they're actually just like slight repair tracks inside the yard. And there you get most repairs, so you don't have to waste the time of keeping a car out on an outbound train by sending it to the shop. If in the shop type setting, you'll have heavier repairs like medium, bad order repairs. And there you usually do a single car air test. So every year, each freight car in the system has to be repaired. You'll be dealing with the AAR, Association of American Railroads. That's how you get all your billing for the foreign cars and also on your own cars. Usually when you have your own car in there, you want to repair it because you want the other railroads to get the billing for that. You'll be looking over probably 40 to 60 guys inside a shop. Out in the yard, you'll probably have about 10 guys for between 3 shifts. And it's long hour days, 24/7. You can get called into derailments. Other than that, there's a bunch of different projects. I don't know. The reason why I like it so much is I'm not sitting behind a desk all day. I'm always out in the field. Probably in a 12-hour day, I'm probably behind the desk 3 hours just looking at emails, doing different things. Other than that, I'm driving around talking to the guys, seeing if there's anything I can do differently, seeing like if they have any ideas that can help me help the company, because they always say that the best guys that improve the work are the guys that do the work. So it's kind of basically just listening to them, trying to come up with new ways to improve things. Recently, UP just came out with what they call a UP way. It's basically like lean manufacturing, and it's unbelievable how much, like before, all the things that they wasted and how much time they wasted just by, I don't know, there's just so many different ways that they can improve things, and it's something so simple that it's like, wow, it really took you 150 years to figure something like this out. So that's why it's such a great time right now to become, I guess, get part of UP, because there's so many ways you can change things. I don't know. Victoria's in one of the system shops. They're a little bit different than like a regional service unit shop. I'm sure I'll talk about them.
Yeah, you know, I work down in Texas in a little town called Palestine. And what we do there, we do everything from what we call program work, where they'll send us, say, 100 box cars that all need similar repairs. And we'll work those. We do everything from complete rebuilds, you know, from the ground up, to a simple, you know, if it needs some work on the wheels and maybe a couple patches on the side. We also run programs for what we call drug cars, where cars that cross over the border will do, you know, you'll find drugs in them, there'll be holes cut in places, you know, and we have to repair those and make sure they're tight so that way they don't put drugs in the same place again. You know, like he was talking about, the UP Way is a really big initiative right now. I don't know, you know, does anybody have any experience with lean manufacturing or any of that kind of deal?
Coursework and.
Okay. A lot of what it boils down to is, like he was talking about, removing waste out of a system. How often do you have to go and look for your tools? How often are you walking back and forth to get material to fix the car? You know, is there a faster way to do it? So there's a lot of initiative like that right there. And the biggest thing is you're working with the people. You yourself are not going to be doing the work. You are going to be managing the people that do it. It's all the union workers that do the hands-on welding, grinding, and we're doing all the repairs.
That's a little different for the engineering department to a degree. When you are training, a lot of the times you need to do the actual work in order to learn the process better. So while at the end of your training, you will just be managing and not necessarily doing the work, while you are training, one of the most valuable tools you can do is offer your service and really learn how to do it. So there's been days where I've dug ditches for 12 hours straight. And it wasn't because I didn't know how to dig a ditch. I mean, we all know how to operate a shovel, right? But it was because I wanted to gain the respect of my guys. I'm not going to ask my guys to do anything I wouldn't do myself. So it's a little different in, you know, civil and electrical than it is mechanical in that sense.
Okay.
And this is just what we hire. We told you what we hire electrical engineers, mechanical engineers for. What we hire operations management or business for is to actually manage the movement of trains. So switching of cars, getting cars from A to B, making sure the train crew, the engineers, the conductors can do their job correctly. So we talk about all this management. We don't hire people off, hire from a college degree and then kind of put you in a position with 30 people working for you. There's actually a curriculum we put everyone through, which we'll get to in a second here. So
I'll talk about it.
yeah.
So yeah, so one of the biggest challenges that you have as an OMT, as we call operations management trainee, is you're working outside, okay? And don't expect to be spending a lot of time in the cubicle. Similar to what Jesse said, you know, you're going to spend enough time in order to do your email and your clerical work, and, you know, maybe get expense reports done from a few weeks ago. But really, most of your time is spent out in the field. So now, like Steven said, you might be really anywhere in the country. So now if I'm working in Duluth, Minnesota, for instance, that means when it's a blizzard like 2 days ago, I'm going to be out trying to work and get projects done. So that